Alrighty, we're back for Advent of Code Day 5. I don't have anything to say, or sorry, Day 6. I don't have anything to say about Day 5 in our recap today because I wrote a post on Mipmaps instead. So if you're interested in Mipmaps, go check that out. It's cool. I need to make some updates to it, but I'm generally feeling pretty good about it. And then we are into Day 6. The Mipmaps post will become a video after I do some modifications. Trash Compactor. Helping the youngest cephalopod with her math homework. That is 2021 day 18. Okay, math day. Let's see. The math worksheet, a list of problems. Each problem has a group of numbers that need to be either added or multiplied together. Each problem's numbers are arranged vertically. At the bottom of the problem is a symbol for the operation that needs to be performed. Problems are separated by a full column of only spaces. The left-right alignment of numbers within each problem can be ignored. That's cool because we can trim the white space. So there's 4 problems. This is 1, 2, 3 times 4, 5 times 6. Cool. Of course, the actual worksheet is much wider. What do you mean by much wider? What do you mean by much wider? What do you mean by much wider? Okay, so there's a lot of problems. They're all vertical. Notable thing here, maybe. Let's see. This is 1, 2, 3, 4. I think this is wrapped. Yeah, so this is one line. This is one line. I'm triple clicking here to check. So there's only one operation per, which is good. Numbers look like they are fairly small, but I have no idea what the output is going to be, so who knows? Let's get started with just create day 6. I'm going to, of course, drop in the answer and drop in the original problem, or rather the input. So question here is, I don't know if we can get away with doing this incrementally. We would have to parse it in reverse, which actually sounds kind of cool. I think we only have multiplication and addition. That doesn't mean part 2 won't include subtraction. There is no subtraction here, so it's all multiplication and addition, which luckily for us, the order doesn't matter. So if we reverse this, then we can end up with a vec of operations, and then subsequent lines can all be operated on. So we can actually do this almost entirely in the parser, which is interesting. I think that what I want to do actually is going to be get the last line and then reparse everything. But we can write a more basic parser too. So let's start with the more basic parser. And then we end up with, I guess we would end up with like a vec of vecs if I was going to do it like that, right? Vec of vec of, we'll call it U64s just for kicks. And then I don't have enough closing things there. Then this is going to be a separated list 1 of separated list 1s of, I think it's spaces that I want. I'm going to check that. And complete U64s. The numbered list isn't that wide, so this is going to do a bunch of allocation. I do want to write a parser later that does this as we parse, but I want to see part 2 first before doing anything fancy. So we're going to do an alt for a tag for plus and minus. And this is basically, I want to check the spaces before I continue. Space 1, okay. 1 or more spaces and tabs. That's what we want because we don't want to handle new lines with this. We just want to handle spaces, like literal spaces, not new lines. So we end up with a separated list 1 of separated lists. This is line ending, separated list of space 1 and use. And then we have ops. Who doesn't have ops? Boring people, I expect. We need the parser trait in here. So this ends up being a vec of U64s and a vec of string slices. That's the opposite way that we have it. So I'm just going to reverse it for the moment. Well, actually, yeah, I think I'm going to reverse it for the moment. Wait for all the alarms outside to pass. Okay, after a brief forced break, we are back. And this is a vec of string slices. This isn't a string slice because we have all of the... And this, of course, is the wrong type signature in the first place. So I guess this isn't really calc at the moment. This is going to be our parse function. I think this is going to be a fun parsing day later. Apparently I can't type today, which is great. So we parse This is going to be nums ops. We run our test and we end up with tag because this needs to be terminated in a line ending because there's a line ending between them. This could also be separated pair instead, which is probably semantically better, right? Because then we're saying this is a pair where we have the first parser and the second parser. Carriage return line fees, space new line. That's an interesting one. There's spaces at the end of the lines. So really the parser here is such that it always starts with a number and then has some number of spaces. And at the end of these lines, there's actually just random empty space for whatever reason. But I don't think that's always true. I don't know exactly how to check it. This one doesn't. This one is just 7 at the end. So optional space at the end, basically. So I'm just going to throw space 0 in there. And what is our input? Oh, we have space at the front too, potentially. Yikes. Just space everywhere today. I think we have a parser for this, actually, instead of just doing this like, right? Like this isn't terminated. This is delimited. We are failing on tag because it's trying to match the line ending. Because now we've got delimited with space on either side, which is valid. But this is really every line. So I kind of have my ordering here incorrect, right? And I'll run this with debug. So we end up with a separated pair, which is I usually break these up into separate parsers for clarity, but today I decided not to for some reason. So we've got a separated pair, right? We've got this as the first parser and this as the second parser. So all the numbers and then just the operations. The numbers are a separated list separated by line endings. Each line is delimited by potentially empty space at the front and back. Inside of that, we have a separated list separated by at least one space. We have a line ending between the two parsers, and then our last parser is also a separated list with space 1. Now, question, because I think because of the way this input works, there will never be a space at the beginning of the operations. And there is a space at the end of these operations. So, actually, is there? So hard to tell. Yes, there is. So there can be spaces at the end. We don't really care about those spaces actually, though, right? Like we can just stop our parser. If we want to do a full parser, we could do an opt space or like a space 0 at the end here. The input does end up getting that space, right? There is technically a space left, but we don't have any reason to parse it because it doesn't contain any data. So I think I'm fine with that. And in the meantime, what we have is 1, 2, 3, 3, 2, 8, 51, 64. These all look like the right numbers in the right order. So what are we going to do? We are going to play the iterator challenge. So I think that the zip in the standard library only takes 2 elements. So we could theoretically just like keep zipping them. And the iterator trait doesn't really have any kind of like multi-zip function on it that I'm aware of. It does have a zip function on it, which you can pass another iterator into. But you know what does have multi-zip? Itertools. But unfortunately, I think this doesn't do what I wanted it to do, which is provide these values. I mean, it does do what I wanted it to do. We just need to know the length at compile time, or rather not compile time, but the output of this is a tuple. So it needs to be able to determine how many iterators there are going to be, and it doesn't accept, say, a vec of iterators to do that, because you do need to pass these elements in as a tuple, which is somewhat unfortunate, because I would like just a slice here. Well, I guess I can't have a slice, now that I think about it. Slices are contiguous, and these are not contiguous, so we would have to collect them into a vec anyway. So then I think the option that we want to do is ops.iter.enumerate.map op. Well, this is going to be index op, right? Because that's what we want, because they're all the same size. And I think this is going to be what are we doing for the answer here? We're doing the grand total of all the operations. So this is going to be a sum. We're going to sum it into a U64 for kicks. And we are going to make use of this index. So we're going to map these values, I think, inner index, and this is going to be nums I inner index. This would theoretically panic if we were out of bounds, but we should be pre-calculating all of these indices correctly, so that is that. This doesn't return a number yet, so that's why U64 is causing an issue. This is a range, so we need to into iterate, and this is not I, this is index. So we end up with an iterator of U64s here, and we're going to match on op, and this is either going to be this, which is it.product, or this, which is it.sum. And it.sum is going to sum into a U64. And I don't think we actually need to specify for product, but I'll check in a second. So this is just going to be 0. I guess we should really panic here, right? And op here is, I guess, a double string slice. So we'll dereference it to get that match happening. These string literals are single references to stir. So if we have a double reference here in op, which we can see through type inlays here, double reference, then we can dereference this once to get a single reference, and then we can match against those cases. I guess this doesn't need to be mute because we're not calling next. Then we get the result, and result to string okay, and that runs the test, and our indices are out of bounds because length is 3, but the index is 3 is interesting. I think these are reversed. They are, in fact, reversed. So in this case, so far, we're getting our parser in. We're doing ops iterate, which is all of our pluses and minuses. Enumerate, so we have the index of the vertical column that we're processing currently. We construct an iterator from those numbers, which is just the series of numbers that we want to operate on using the indices that we picked up. I'm going to get rid of this input for that warning. We match on op, and then we either use product or sum to either multiply them all or sum them all. I assume that we're going to have to change this in part 2 because that seems too easy. But let's see if it works for our actual input first. Yay, that is the right answer. Cool. So we got to do some cool iterator stuff today. That's fun. I think I didn't quite remember the way that multi-zip worked in itertools. I don't feel like I have occasion to merge arbitrary lengths of iterators that often. But this is easy enough. And we bench at 60 microseconds for that. So I assume that a lot of that is actually going to be the allocation for the parsing, but TBD. So we end up with the big cephalopods come back to check. Cephalopod math is written right to left in columns. Each number is given its own column, with the most significant digit at the top and the least significant digit at the bottom. Problems are still separated with a column consisting of only spaces, and the symbol at the bottom of the problem is still the operator to use. So here's the same worksheet. This is what? Right to left in columns, and each number is given its own column with the most significant digit at the top. At the top? Oh. Okay, so this is like 365, and this is 369, and this is 248. Is that the way that this is working? 4. Where's 4? The rightmost problem is 4 plus 431 plus 623. That's annoying. So these are very specifically lined up, though, which is interesting. So I guess this is going to turn into like a parsing day. Let's throw this into part 2. Let's say the grand total here is this. So I feel like we basically need to transpose this, honestly. I guess we can technically lockstep it through all of the columns, which is, you know, not my favorite. We could get the whole chunk of numbers, and we could get the operators, and then we could do an additional parser on each of the lines in reverse. We would have to do individual characters and maintain the order. I guess really, if we're going through all that effort, this is like made to be, I don't want to say an easy parsing problem, but you can just dot iter over the spaces kind of parsing problem. It's not clear to me if there are guaranteed to be 3 numbers. Each of these has a 3-digit number that doesn't necessarily, so there are 4-digit numbers in the actual input, so we can't guarantee anything about that. I think we can assume that there's one space between all the problems. So if every sort of parser, so to speak, ends up with a empty space, then we end up with like the space between 2 numbers, if that makes sense. I guess that's not technically true. There's nothing that said that it had to be like that, and it's just set up really annoyingly to check. I I think that's true though. Let us look at our actual input just to make sure that we are actually parsing this in a way that is congruent with the way that things are supposed to work. I think if we do a parser that is basically gives us the operators and then the rest of the chunks, which in regular Rust would be like iter lines last to get the operators in the right order. I do feel like there is one space between all the problems, so that's pretty guaranteed. If we have a space for all of the columns or all the lines, then we end up with like a gap between problems, if you will. We can also take each of our vecs and does alignment matter? Hang on. Alignment matters, so we can't just parse like a 7 here and expect it to matter, because this has a 7 on the left and this has a 7 on the right. So there's really there's no way we can cheat that. We kind of just have to lockstep it across all these byte by byte, which is kind of wild, honestly. So really the question is, how do I want to do this? Because we know that we basically have to have like 4 iterators and then just incrementally iterate over everything. We can just do that, right? We can iterate over these lines and basically collect that into a vec of iterators and perform operations based on whether they are all spaces or not. I think they all end at the same spot, right? So we're guaranteed to start off well. So we do need to parse the operators. We could start with a series of iterators in reverse for the lines. And then for each of those, how do we define these numbers? 4, 4, 3, 1, 6, 2, 3, 4, 4, 3, 1, 6, 2, 3. So top to bottom, right to left. So I don't think we actually get a lot from using nom here, because the way that nom is supposed to work, right, is basically byte by byte, right? So we go from beginning to end, beginning to end, beginning to end. We can do things like parse this chunk and then parse the rest and then operate subparsers here. So we could do that kind of thing. The issue with that is we'd basically just be chunking through individual reversed byte parsers anyway. So I think we ditch the nom parser actually. I think that the nom parser probably still makes sense for the last line. So let's say ops here, right? So we end up with this ops parser that just gives us the ops, and we end up with like input.lines. I think we confirmed that the operators always start with one of these two. So let's see, let mute ops equals vec. Let's do input lines with position from itertools. Let's just get a iterator container here too, I guess. The iflet, I think position last. Basically, I want the last one here, but I don't want to have to like track it. So if we're in the last, then we want to basically run the ops parser here. I'm going to rename this just for clarity. Operations. This is going to be operations. So we run the operations online. We end up with a stir and a vec of stir. Otherwise, we reverse iter the line by cars. Does that sound right? Right. So we end up with a vec of iterators of cars that are all in lockstep, and then we end up with ops, which are all of our ops. We need to reverse the ops before we stick it in there. So ops equals output, because output.reverse I don't think returns the actual value, right? Reverse, mute self, no return type. So we reverse it and then we set it to ops such we have it, which should be the right order. Cargo test day 6 part 2. This isn't compiling yet because I didn't finish what I was doing down here. So we have basically all the operations in reverse order and in a vec of all of the iterators that we need to iterate over for each character. So for each op, we need to find a way to get our list of numbers. And our list of numbers is basically going to be the length of its and some calculation We can just hit next for all these, so that's nice. I feel like the unfortunate part here is just spending some time about thinking about how to set up the data here, because we can do just an iterator over each of the iterators, right? Right. It's dot iter, and then we have a line, which is the reversed cars, right? And then line would need to be, so this would need to be iter mute first of all. And we can call line next in here for each of them. And that gives us option car. We really care about these options. This is going to give us the top to bottom ordering of these characters. There can be no spaces, so we have to have at least a number, and we can ignore all spaces, I think. The problem with that is we probably want to reverse this, right? Because we end up with the number 4 if it's down in this position and we're iterating top to bottom. This also needs to be mute to be able to be reversed. So we end up with, we can get a front to back iterator from a vec deck. Can we get a back to front iterator? I guess we have to reverse it, so it really doesn't matter. I was kind of hoping there would be a utility function here that would do like a back to front iteration. I don't think we have one. So we really when we iterate here, what we want to do is iter mute.reverse or rev map. And now we're dealing with the ones character first. So we enumerate, we end up with the places number as well as the character, right? So this can be a filter map now. This can be next dot map character as digit 10 unwrap times, I think places is usize, which is fine. And this is actually just the return value here. And this is going to be something like a number incompatibility between two types. So we've got like a U64 and a usize or something like that. The product stuff, we should probably just comment out. U32 times usize. So we can just make this a usize, or we could make this a U64. Either one works. I think I want to claim both of these as U64s. Just thinking about the way this is going to work. Basically, this is iterating over the lines in reverse order for each character. We filter map with the places in the line. If there is nothing, then this filter map doesn't run. And this is going to be impl U64. So if we do this, do we get access to is empty here? I don't think so. The filter map will take this down to each of the digits that we have in the right order. The question is, if we do product here, we end up with that resulting number, right? Which is good, except for the fact that it's either going to be product or whatever, right? I guess there always has to be a number unless they are all none. So we could do the none check ahead of time. I'm trying to think of a way to avoid doing an extra check here. What happens to product? Well, product is going to be the wrong thing here, right? It's really a match on ops that we want to do. So it's really this. Question about result here. Type annotations needed must be known when we call product. Sure, this is a U64. Or rather, this is an iterator, right? We need to not call product here. And this is going to be an iterator of U64s, and this is going to be just something. We're just going to debug T out for the moment, because we've gone quite a while without actually running the program. Borrowed after move because ops has a vec string slice, which doesn't implement copy. Borrow occurs to deref coercion to a slice. Oh, because I'm debugging it? Oh, whoops. You know, sometimes it really do be like that. Okay, so option unwrap on a none value on 38 because C could be a space. So how do I want to do this? This can be line next and then do this. C to digit, which hopefully works. Map digit times places. Let's do these casts as U64. This is a U32. Oh, right. This is an option. So let's do the cast down here. So we end up with 4, 72, 25, and 1. That sounds completely wrong. T is the addition. So let's do infos here to see what is up with our digits. We need to bring this into scope for tracing. We need to set our test here to test log test to be able to output that info log. I don't need the input. I like leaving the input here, even though I skip it most of the time, because sometimes it is useful. So we end up with 4, 1, 3, 4, 3, 2, 6. 4, 1, 3, 4, 3, 2, 6. That looks right for that column. 4, 1, 3, 4, 3, 2, 6, right? 4, 1, 3. Oh, it's. Wait, it is top to bottom? Hang on. I thought it was. Why did I think it was bottom to top? Oh, it's bottom to top because of the places, but it is top to bottom for the number. So if we do an additional log here for. Ooh, let's do. This is a product, I think, actually, now that I think about it. Because this is our number, right? And they all need to multiply together. And we'll make result a U64. And we end up with 472, 216. 472. Where does 72 come from? That's just wrong. 472. 72? Is that 4 times 3 times 1? That's wrong, right? Let me do digit and inspect value. And we're just going to info this value. So we've got a 4, a 1, and a 6. Because I'm using places and it needs to be, what, 10.pow places? IPOW? 10u64.pow places. Does that need to be u64? What is places here? Oh, it needs to be a u32 if I remember correctly, actually. So test for part 2, we will go look at our logs again. These are clearly, very clearly wrong. Very clearly wrong. So we don't need to be producting these anymore. I think we just need to be adding them. So we end up with what? 40 here, which is interesting. Why is it 40? Because a number comes back at 0 at some point. So what? 10 to the 0 is 1. 40, 10, 300 is 4310. Where's that extra 0 coming from? It should be what? POW minus 1? Okay, here's our 431. I guess we'll get a result that's 4. Yeah, 4, 431, 20. 4, 431. Where's 20 coming from? Oh, that's not the right thing. Never mind. Result. That's what I get for naming all these things similarly length words. 4, 431, 623, 0. 4, 431, 623, and 0. And this does it once, right? Right. If we info, index, and op, then we see that this only occurs once. Index 0, op plus, index 1, op star. Oh, that's wrong, actually. Doing these iterations, the iteration needs to happen inside of this loop until we get that 0 number effectively. The question I have is there any 0 in this entire input? If there isn't a 0, then we can check for whether this is 0 or not. Oh, there's no 0 in this entire input. There are no zeros. There is 0% chance to have a 0. Okay, that's cool. Because that means that for all of this sort of work that we're doing, if this sums to 0, then break the loop, basically. And this can just be loop. And at this point, like, is it really valuable to do this again as an iterator? Not particularly. We just kind of keep going until we need to break, and then we do it again. So I think that we're just going to let mute result. No, I can't call this again result. This is gonna be mute output equals I guess 0, right? We'll never have a 0. So, and this is match op in here, right? With the same match but different overall operations. We no longer have like an iterator of these things to do a product or a sum on. I guess theoretically we could, but I can't think of any way to know ahead of time how big these numbers are going to be. We have to iterate 4 times according to the input, but I don't want to hard code that. We have to iterate as many columns as there are, which could be 2, could be 4, and we won't know. So this is just going to be the way that this goes. This is going to be output times equals result. And this is going to be output times equals or plus equals result. And probably throw these into some brackets just so it's clear that we're not like really returning anything here. And then we result, and then we output, and our output is going to be our output, and those are all going to get summed, and we are going to fail because let's get rid of some of these logs. I think that the value log is probably not super important right now. The digit log is probably not super important right now. I think I want a log for the result because that'll give us a good way to track our debugs. So we end up with 431, 623, 175, 581, 32. Wait, 175, 581, 32. This one becomes 800, 248, 369. So that's an issue. 356, 240, and 100. 356, 240, and 100. So we are still having a couple parsing issues. We also have a separate issue. We have two issues that I can see here. I think one of them is that this result becomes 0 and that we're actually applying that. So we do a sum here. So this output actually shouldn't matter, right? If output is 0 for this operation, which it should only be for the ones in which we're skipping. Ooh, actually, we need to run an additional next, now that I think about it. I think we're not checking for if this is, right? Iter enumerate map, info index op, and we end up with index 0 op plus this. Maybe I should print the output here. I don't think I can really though. Let's do info output here. I keep making the logs bigger. In actuality, I think I could change my subscriber to remove the timestamp and things like that. Things that I'm not really interested in. I just tend not to. So we end up with 1058 and we need a 3253 600, but we end up with a 0. Why do we end up with a 0 there? And then we've got 175 8132. Why is that 0? That's one of our issues. So I think we'll deal with that in a second. We do need to deal with the fact that these are coming out as 800. Why is this coming out as 800? That I don't think I could tell you. This has 2 spaces going all the way up. Why does this have 2 spaces going all the way up? Hang on. Does this have 2 spaces? No, this has 1 space. Did I miscopy the test input? No. 1, 2. Huh. Hang on. 51 is lined up like that. No, that is 1. Okay. Why are we getting 800? Because of this? So really it's not times the index, it's the index afterwards. So this is just 8. That feels really weird. So you can have an 8 anywhere and it's a ones digit. That's just weird. Okay, let's do C to digit, map digit, digit as whatever. We're doing an enumerate here, right? I guess we should call its lines, really. The lines intermute, reverse, enumerate. This enumerate isn't actually the one that we need it to be. We need the enumerate on whether this digit exists or not. We need it to be on the first actual number we see, not on the place it is. So I think if we filter here with 2 digit, right? Line next and then C2 digit. We want to filter map here, which gives us the digits, and then we can enumerate, and then we can take this and do digit, which is actually places digit and has already been unwrapped for us by virtue of filter map. So we then don't need to filter here. We can just map, and we end up with, it tends to subtract with overflow places. Right. Just remove that for a second. So we end up with 4, 431, 623, 1018. And then this is 8, 248, 369. And this is 356, 24, 1. So these are the right numbers now. The outputs are not right, but these are the right numbers. So we're supposed to get 1058, a very big number. This result is an issue, right? If result is 0, Oh, we need to break here. We need to break before that match. And I will continue to log result out here, I think. So the question is, why is output 0 here? Output is 0 here because we're looping. We do the filter map and the sum. We filter out everything until it's 0. So the addition is fine and the multiplication is not, is what I'm seeing. So the multiplication is multiplying by that 0, right? Which means that this is multiplying by 0. But how would it be getting there if it was? Because we break when you're equal to 0 here. Let's do output inner and just track this value, right? So this is always 0 to start. Then it's 4 here. So it's 0 times 0. Yeah. Okay, so because this is 0, this becomes 0 because 0 times 0 is always 0. So the op actually needs to get set based on the operation, kind of. So match star 1 plus 0 underscore panic. And this has a never type. What did I do wrong? Oh, because I'm matching on nothing. We're going to match on op, which I didn't mean to make a reference. I meant to dereference. So test. Now our tests pass, which is great, I think. Where's our test? There's our test. So if we run part 2, we end up with some logs and a number, and this becomes our gold star answer. Huzzah! Let's get rid of some of these infos and debugs and stuff, and we end up with a 50 microsecond solution, which is actually faster than our original part 1. So 64 for part 1, 52 for part 2. We'll look at the mean. About a 10 microsecond difference. The process function here takes the ops, and I guess I shouldn't really name this its. This should be named lines iterators, something like that. Some of these can get underscores because we're not using them. So we get the operations and the lines iterators. We use itertools to determine whether we're on the last one or not because we handle that specially. If we are not on the last one, we push an iterator, which is the reversed character iterator for each line into this vec and keep them around for a while. If it is the last one, then we have all of our operations and we reverse that and set that as ops. So we're doing this whole thing in reverse, basically. We're going to do a reverse iterator on the operations, and then we're going to do multiple reversed iterators on each lines individually. We start off by iterating over the operations. I don't know why I enumerate this. I think it's just for like a sanity check. We aren't using the index, so I'm going to remove it here. So if we iterate over the operations, reverse order, this is going to be either star or plus. We don't parse that into an enum. We could. That would help us get rid of this panic here, which would be really nice. If we're going to do multiplication, the identity for multiplication is going to be 1, and the starting value for addition is going to be 0. We can assume here that we basically always get at least a number. So this is just our starting point. For the loop, then, we take each of those lines, we iterate from bottom to top, because the ones place is the bottommost character, even though the bottommost character doesn't need to be at the bottom, as we've discovered. For example, if I move this input here, this 8 is just an 8. Like it is just 8. And this 4 is just 4. So if there is only one number, that is the ones digit place, regardless of if it's on the top, on the bottom, or, theoretically in the middle somewhere. Which is kind of weird, but, we're vibing with it. So we go from bottom to top because the bottommost digit is the ones digit. We filter over each of the characters, trying to parse them into a digit. If we can parse them into a digit, then we enumerate, which gives us the places component for each of our numbers. We do our multiplication here, digit times the places. So this gives us the ones digit, the tens digit, the hundreds digit, so on and so forth. We can sum those all together to get our actual number that is vertically oriented, ones place at the bottom. Or I guess not ones place at the bottom, it's ones place like, anyway. um, if our result is 0, that means that this 2-digit basically filtered everything out because we don't have any zeros in the entire problem. That is critical information, right? If we sum this together and this is an empty iterator, right? If we filter everything out here, this returns 0. So if that is 0, then we have an empty column. And otherwise, we apply our operation, move on with our lives, sum them all up, and we're done. And with a 50 microsecond runtime, I am mostly okay with this. I think the things that I'm not okay with that I would probably change are things like multiplication and addition here requiring a panic in this match. You know, we're going to parse these out anyway. So realistically, when we parse them, they should become an enum or of some kind of data that allows us to match here and know that we only have multiplication and addition at this point. It's advent of code, so I think I'm going to leave this for now at least. And then it feels like there's a lot of assumptions which are kind of baked into the problem, and I'm not sure how to encode them in an obvious way other than leaving comments in the code, right? This is very much like a non-intuitive way to parse numbers. We're parsing from like right to left in columns, and the ones digit is whatever number happens to be here from bottom to top, right? The idea that there can be a number here and that means the same thing as a number here feels really strange. And I don't know of a way to encode that in an obvious way other than leaving a code or leaving a comment in the code. Maybe if we write a better parser for this, it will be more apparent. But overall, this is just like a weird way to parse numbers. This would probably, if I was writing this in production code, this would be a place where I would want a ton of tests. I think the other thing that I'm not super happy about is this being 0. If this is 0, then that means that we are that we don't have a number. I tried to write this in a way that didn't encode specifically that there were going to be 4 columns or something, or 4 rows or something like that. So maybe it actually makes sense to make this like a scan of some kind. Not this part specifically, I don't think. I think at least like if this was some kind of scan, we could encode the fact that there, maybe. I'd have to write it out. But basically, I'm not super happy with the fact that 0 means that we don't have those characters. We could, again, like I said earlier, do a check here. So we do the filter here, right? We could stick this in its own iterator, clone that iterator, and check to see if it's empty or something like that. Or we could use peek. We could run an iterator with peek, which would call next, but would also allow us to then not call next like multiple times. So I don't know. There's options here. I'm sure that I'm probably 199% sure that there is like a better shortcut trick to do here that I'm not aware of right now. But as far as today's problem goes, I think I'm okay with this for now. I might try to refactor it. Trying to write it as like an inline non-parser could be really cool, right? Like do the operations as we're doing the parsing. But we'll see. I don't know. I'm curious to hear how you decided to solve this. So leave that in the comments, and I will see you in the next one.